I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
All right. Hello, everyone, and welcome to Building AR Apps using RealityKit. All right. Here's a little bit introduction about me. My name is Mohammad Azam. I'm an instructor at Digital Crafts. I'm also teach a lot of courses on Udemy. I have some licensed content on LinkedIn Learning. I've written a couple of different books, including on ARKit. Like to do indoor rock climbing in Houston, and like to come to Colorado to explore. All right. Now, this will be a very, very hands-on kind of live kind of a session, but a couple of slides I'll just show you to set the context. ARKit was released in 2017, and it used the existing technologies, meaning SpriteKit, SceneKit, and Metal frameworks to create AR experiences. SpriteKit, SceneKit, Metal, they're all basically used for gaming. SpriteKit is for like 2D games, SceneKit is for like 3 orthogonal games, and Metal is those like for hardcore games. RealityKit was released in 2019, and it was created from the ground up, meaning it was completely a brand new framework. I'm not sure what's going on with the over here. Realistic rendering and simulation, and it works on iOS as well as macOS. The architecture for any kind of a RealityKit application is kind of like this. It revolves around 4 different pieces. You have AR view, anchor, scene, and entity, and that's it. Once you learn these things, mostly the entities, you will know how to create RealityKit applications. AR view kind of like sits on the top. It sets up the environment. It handles the gestures that basically focuses on the app. And it does allow you to create realistic camera effects. So everything that you're going to see using RealityKit using AR view, it looks very real enough because of all the shading and light and all that stuff. Everything that you're going to put on the screen, put on the virtual object, it will be an entity, everything. So you can think of it as a virtual car, well, that's an entity. A virtual sofa, well, that's an entity. So anything that you're going to put in the real world, that's going to be an entity. Anchors are actually the most important part. Anchor is simply going to tell the entity where to go. So if I have an anchor, which is like a plane anchor, horizontal plane, it means that it's going to be right over here, right on the carpet, right on the table. If I'm putting a vertical anchor, so it might be on the wall and things like that. You can also have anchors on your face, so something will attach on your face. So anchor is kind of like attaching an entity to something. Camera anchor, image anchor, you may have already seen these kind of demos where you have an image and somebody looks at the image and the image kind of pops out and there's the virtual content. That's the image anchor. Body anchor, it will attach to your body. Object anchor, kind of like you're visiting a museum and you see a sculpture, and if you just look at the sculpture with your iPhone in an AR app, it will pop out and it will give you a little bit more information. Let's take a look at a very simple example. We have the anchor. Anchor can attach entities. How many entities? Well, that's up to you. I'm just going to attach 2 entities, meaning one can be like a car, one can be like a train, a virtual car. And then if I move this anchor and put this anchor on a kind of a place, meaning like kind of like a vertical place, then all those things are going to move and attach it over there. All right. And this is kind of like the overview diagram. You can see AR view kind of like sits on the top. Then you have a scene. You can think of a scene just like a movie scene. one scene can have, depending on if a scene is shot in a restaurant, then the background is restaurant. If a scene is shot in a battlefield, then you will have like the mountains and the grass and all those things, the rivers maybe in the jungle. And then you have anchors, and each anchor can have one or more entities attached to it. All right? And that's it. That's all the slides I have. I'm just going to show you live what's going on. All right. Everyone can see on the back? All right. Okay. So this project, I have not really added anything. If you create a new project in Xcode and you select Swift UI, you select the augmented reality template, and you select Swift UI, this is what comes up with. Now, I have added some files, but we're not really using it right now. All right? We're actually not going to use anything that this is doing. But let's go ahead and run this and see what happens. So hopefully, and this is the difficult part. So this is my phone. You have to have a phone, a physical phone, whether iPad or a physical phone, for the augmented reality apps to work, or else they are not going to do anything. If it doesn't work, then I have a backup, don't worry. Okay, here we go. Come on, come on, come on. Not sure why it's taking so long, but here we go. Okay, so the augmented reality demo that Apple has created by creating a default app, what it is supposed to be doing is trying to find a plane, all right? And that's going to be a little bit hard part for us. Oh, here we go. You can see that? So it found the plane. It found the plane. It was kind of hard to find, and the reason it was hard to find is that this black surface, it cannot really see the patterns. It's very black. There's still some texture in this black surface, but luckily we were able to find it. Now I have to move a little bit slow. That's why I've got this long wire, so I can go close to it. And I haven't really written any line of code. All right? So it looks really good, right? I mean, it's like metallic kind of thing, and it kind of reflects the light. It reflects the surrounding. So that's the first demo you're going to see with ARKit without writing a single line of code, is this box. All right, I have to be very careful with this. Okay. Now we're going to write some code to make all of that happen, but what Apple is doing is Apple is using this Reality Composer file to load something. Just think of Reality Composer as a place where you can create your reality views, like a reality scene. You can drag and drop stuff and do all of that stuff. That's fine. We're not going to do that. So I'm just going to delete these two lines. Okay? So now we have nothing. The first thing and the only thing we're doing is creating the AR view. We need that. That's kind of like sits on the very top. And since this is a Swift UI project, it is using UI view representable. All right. Now, Swift UI by default does not have a AR view. It just uses whatever UIKit provides or whatever. Yeah, UIKit provides, and it exposes it using UI view representable. Okay. So you can use Reality Composer, drag and drop stuff, that's perfectly fine, but I'm here to show you how you can do it by writing code. So the first thing is what we want to do is to create a box. Just a box, just like the box that we created earlier on, we want to create it using our code. Model entity. So everything is an entity, right? We learn everything is an entity. So if you want to create a box, we're going to use a model entity, and we're going to pass in a couple of different things. There are many different overloads over here. I'm going to use the one that contains mesh and the color or the material. Mesh simply means the overall skeleton of what you're trying to make, like a mesh, like a scaffolding. You're going to see that over here we have different options: generate text, generate sphere, generate box. Yeah, generate box. 0.3 meters. Everything is in meters. 0.3 meter is actually pretty decent size. 1 meter is actually pretty big, so 0.3 is okay. And the second argument is the materials. Material means how are you going to cover the box with? So if you look at our example, like us humans, my material might be this blue shirt that I'm wearing. So what do you want to wrap your box around with? There are many different kinds of material. I'm just going to use something called a simple material with a color green and metallic true. Metallic means that it's going to reflect the light. Next, we need to create an anchor because anything you want to put in the real world, that needs an anchor. So we're going to use anchor entity. And we will find the anchor, which is the plane anchor. The horizontal anchor. Now keep in mind one thing. This is only going to be available to you if you're hooked up to your actual phone. So if you're hooked up to the simulator, this plane overload is not even going to show up. So that's the number one thing. Always when you're creating AR application, always make sure you're connected to your phone or iPad or something physical device. It cannot run on a simulator. So we got the anchor. The only thing now next to do is to add that anchor to the scene. ARView.scene.add anchor, anchor. And that's it, done. So we recreated the same example with a green text box, a green box. Now again, it's going to take some time to find the plane because this is not really a well-lit area, but hopefully it's going to find it. Yeah, see, it's taking too much time to find over here the plane. So let's move a little bit over here. Let's see if it can find it over here, or might have to run the app again. Nope. I think it actually died at that point, at that time. All right. So let's go ahead and run it again. Sometime I think it happens, it just fails to find the plane, the horizontal plane. So hopefully now that part will be a little bit more textured. No, still not finding the plane. All right, that doesn't look good. Unless I made a mistake. Let's see what's going on over here. Oh, of course. We never really added the box. Duh. All right, so make sure that you add the box to the anchor. That's what you want to add. There we go. Let's try it again on the black surface because I can reach over here and that might be a little bit hard to reach. All right, hopefully it will find on the black one, but let's see. Here we go. All right. And I can go near it again with the same thing. You can see a little bit of a shining thing, metallic thing going on, and I can go over it and I can see it from all the side. Looks nice and shiny. If you don't pass is metallic true but false, then it will be very bland, like no shining, nothing. I don't like that, but you can try it out. All right, just like a box, we can create some other things also, like a sphere. And the syntax will be exactly the same. We're just going to use a different mesh to create that. Model entity, mesh, and in this case, we can use a sphere with a radius 0.3. And the materials, again, simple material with the color red and metallic to be true. We can create a different anchor, but who cares? We can just add it to the same anchor. And then sphere. And there we go, run it again. So now we should have sphere and we should have the box. Once again, it's going to take some time because it's not really a well-lit area. Let's see if it might actually push it out somewhere else. It's taking way too much time than I would like it. There we go, a little bit more light. There we go. All right. But now the question is, well, where's the box? It's inside of it. So I can't really go that far, but trust me, the box is inside this sphere. There we go. A little bit more. There we go. See that? So now what we want to do is we want to put the sphere a little bit on the top so that it doesn't cover the box. So if you want to change the position of something, you can simply say position. And you have three things to change. 0 meaning x-axis, y-axis, or z-axis. So we're only changing the y-axis. We're just sending it 0.5 meters above from the center. So you might be able to see the box and the sphere at the same time now. Once again, I think it's taking way too much time to detect it. So let's see if we can just push it over here maybe. There we go, much quicker. But it's too far for me to reach now. But you can see that we have the sphere and the box. All right. All right, so this all looks fine, but what about if I want to interact with these virtual content? What about if I want to tap on the sphere or tap on the box? How can I do that? Now, for that, we will create a coordinator which is going to handle all of those events, like a tap event. All right, so let me go ahead and create a coordinator. Since we're using UI view representable, it already comes with a make UI view, update UI view, and a make coordinator, which you may have already used it. But currently we don't really have a coordinator, so I'm just gonna use the same file. And I'm just gonna say AR coordinator, and it will have access to the AR view. We will pass the AR view to it, and we will create a function like a normal, not this one, Objective-C function, which is tapped. This will be our recognizer, meaning the tap gesture recognizer, which you may remember from UIKit. Over here in the make coordinator, we're just going to return the coordinator. There we go. And now inside the make UI view, we need to set the AR view for that coordinator and also the tap event. So context.coordinator, which is the AR coordinator, .AR view is AR view, and AR view dot, it's just a normal view, UI view kind of thing, well, with some other stuff added. And the person who will be in charge of handling that will be the context.coordinator, and the person who will do all of that will be the tap event. This means that whenever I will tap on the AR view screen, the AR view is going to handle that, and then it's going to forward that request, the tap, which will be handled by the coordinator.tap function. So now it's a responsibility of the coordinator to get the element that you tap and then change the color. So how do we get the element? Well, first, let's go ahead and unwrap this. Because you can see on line number 19, I made it optional, so I'm going to unwrap it. And now I can say recognizer dot location in view. This is going to give me the location in view, but look at the location. It's simply a CG point, meaning x-axis and y-axis. So now we have the location of your tap, which is just the tap of your screen. We need to find out the actual entity that you have tapped. And that is where we are going to take help from the AR view. AR view.entity at a particular location. We will get that particular entity. Everything is an entity. Now you have got the entity. Well, you can do whatever you want now. But make sure that you cast this entity to be a model entity so that you can get all those model and all the materials. So once the entity is tapped, I'm just going to go ahead and change the color to a random color, which is an extension I've already made, and it will be metallic. This UI color.random is just some side function extension that I've made. It just returns your random color, that's it. If you run this right now, it's not going to work. It looks like it should work, but it's not going to work. And the reason it's not going to work is that your box and your sphere are currently not really tappable. They're saying that we cannot allow you to tap us. All right, so we need to do a little bit more stuff. When we created the box and we created the sphere, we need to say generate collision shapes, which simply is saying that, yeah, you can interact with us. You can find out our shapes. And when you tap, you can tap us, basically. And I'm going to do the same thing for the sphere. If you don't do that, they will not be tappable. They will not take part into any collision and like physics. Okay, so hopefully now it looks like it may work. So let's go ahead and run it and see if we are able to do it. Now, it's not going to be 100% accurate tap. Like I have to tap a little bit lower to get the tap working. So you'll see. And let's see if I can get it to be close by to me so I can actually tap, or else if it's too far, there we go. So I can tap the sphere, but I have to kind of like sit down and tap on the bottom. You can see it's kind of hard to tap on the bottom, but there we go. But sphere is easy to tap. And you can see it's just assigning some random color to it. All right. So you can basically interact with your virtual objects by tapping. All right. Okay, so this is great, but let's take it one more step further. Currently, the only box and the sphere is added when it finds a plane, and I just put it right there. But what if I want to add multiple boxes? Every time I tap, I want to add a box. All right, so how can we do that? Let's go ahead and comment our Discord. So how would we do that? We need to use the tap event, which I'm already doing. But inside the tap event, what I want to do is using my iPhone or iPad or any compatible device, I want to perform a raycast. The raycast is going to go, cast a ray, it's going to hit the ground. If it finds the plane, then it's going to say, yeah, I found the plane. You want to put something there? And I'll just put something there. So let's do raycasting. Raycasting is a feature of AR View. You can see that there is a function called raycast. And it tells you from where you're raycasting and what are you trying to hit. Well, from where I'm raycasting is where I tapped, so location. Do you want to raycast to an estimated plane? Like you don't even know the plane? Yeah, I'm just gonna say estimated plane. I don't know the plane, how big is the plane is. And do you want it to be horizontal or vertical? Well, I can't really do it on the wall. I think it might be very, very clean surface, or it might be possible, but it's kind of hard. So I'm just going to do horizontal. This is going to give us a results, an array. And this array will contain raycast result starting from the closest one to me. It usually mainly returns only one item in the array, so I just want the top item or the only item. If let result equals to results dot first, just give me the first element. Most of the time it's only one anyways. In certain situation it can be more, but this raycast result will have all the different information about the point that is intersected on the ground or on the platform or on the carpet. And that is where I can put something. So I'll create an anchor entity using the raycast result. So that's kind of like a helper function that is already provided by the RealityKit. Now I have an anchor. I've tapped on the screen, it raycasted, there's an anchor right there, but there's nothing attached to the anchor. So what do we want to attach to the anchor? Well, anything you want, basically. Any model entity. How about the box? So let me go ahead and comment out this part. And where's the box? So let's get this box. We will create a box with a random color. We don't want 30 red boxes or green boxes, just create random boxes, random color. Anchor.add. To the anchor, add the box. And then the most important thing, add the anchor to the scene. If you don't add the anchor to the scene, then obviously that particular anchor and anything attached to that anchor is not really part of the scene, which means you won't be able to see it. All right, let's go ahead and run this and see if we can add multiple boxes. Whenever I tap, I should be able to add multiple boxes. Now, we should hopefully see the green box because that is added when the plane is detected. So let's see if we can figure out the green box. There we go. So this means the plane is detected. Because that box was already, we are adding it whenever the plane is detected. And we can also add multiple boxes. It's kind of hard to detect the plane. Let's see, there we go. So we added a couple of different boxes. I think I might have to go a little bit over here. All right. So now you can see that we are able to add multiple boxes, or any kind of a model that you want to add, sphere, boxes, whatever. There we go. This is, I don't know why it's so big, but I think it might be resting on the platform rather than anything else. And you can see if you add this, it kind of weirded out. Not sure what's going on over there. All right. So it's not that hard to add like multiple virtual objects on the base of a tab button. All right. Okay, so we have learned how to detect a plane. We have learned how to put some virtual objects on the plane. We have also learned how to put multiple items based on our tab. Now, another thing that you can do is what we experience in real world. Let's say, Ed, hold on a second. What's going to happen if I do like this? If I just let go of the wallet? It will just fall, all right? So the forces of gravity is going to act on the wallet or on an item. It's just going to fall. So why can't we just do that in our augmented reality also? So augmented reality objects can also work under gravity, making them more realistic enough. All right, so let's see. And you'll see that it's quite simple to add like a really basic physics to it. But if you want to do something crazy like collision detection, then it becomes a little bit hard. But I'll show you an example of collision detection also. I'm not going to type it out, that's too much code, but I'm just going to show you that example. All right, so let's do gravity. So we have the box. Now gravity or the physics comes into three different categories. A dynamic body, which means if I just let something go in, it just falls. A static body, which means like a mountain you cannot move, or something very strong like this thing we cannot move. And kinematic, which means that you can move by like if you want to move. All right. So I'm just going to go ahead and use, and by default it is dynamic. So I'm just going to go ahead and assign it the physics component. You can pass in many different things to the physics component, like the mass and the density and the shape. Like if you have like a really complicated thing, you can actually pass in a shape too. But right now, I'm just going to use physics component. And I will also set, even though it is already set, I'm just going to go ahead and set this to be dynamic. But it's already by default set to dynamic anyways. And that's it. All right, now you'll see, and also, one more thing you should do definitely is we want the box, when I add the box, I don't want it to be on the ground. I want it to be a little bit up so you can see it falling down. So the same syntax, position. All right, so 0, 0.5, and 0. So just y-axis, just make it 0.5 meter above the ground. All right, so let's see that if we are able to do that. And let's see if we can detect it over here. This is a little bit close by, so we should be able to do it. We should see a green box whenever the plane is detected. That's our hint that the plane is detected successfully. If we don't see the green box, then it means it's still working, or it kind of like failed to detect the plane. So you can see it's still working. It's not able to detect anything right now. Here we go. All right. So now we're 100% sure that the plane is detected, which might be this platform where I'm standing. Now, if I add something, so we got like halfway there, but you can see there's something wrong. It just goes into infinity, right? So the question is, how can we make it not fall forever, right? Now, there are multiple ways you can do that. There is something called a plane shape, which is a two-dimensional shape, like paper. A paper is a good example, or kind of like this. This is kind of like a plane. You can put the plane on the floor with any color or clear color, meaning it will have no color at all. And you have to put like a much bigger plane because you want to put something else. Or we can just use our already existing green box, and we can just make that static. That will also take part in the physics. So let's go ahead and do that. So here's our green box, this one. We can just type it green box over here. And we want this box to be part of the physics. So we're just going to go ahead and say box.physicsBody. Just use the default physics body, which is already like a cube. And this time your mode will be static. So you're not going to move. Whatever happens, this green box should not move. This is going to be rock solid. This is kind of like a mountain. You cannot move. Okay, now let's see what happens. All right, so we're going to run this. We're going to wait so that our green box can be detected, or the plane can be detected. And since this is, again, kind of like a very hard surface to detect the plane, it might take a little bit of time. So it's always a good idea to have like a well-lit place with more patterns. You can see it's taking literally forever. Maybe it already died or something, but let's see. I don't think, here we go, okay. That's a lot of time to detect a plane, by the way. All right, now if I go ahead and add another object, I mean, I don't know how many I can stack on top of each other, it's kind of hard. Here we go, one more. There we go, no, okay. So you can see that I can stack like a little bit of more items over here, all right? And the reason is that the bottom, the green box is static, so it's not gonna move anywhere, but the other boxes, well, they are dynamic, so they're able to fall on top of it. All right? Now you can go ahead and make the box bigger if you want to, change the size, the depth, and your green box will be much bigger and you have more area to play around, and you can definitely do those things. All right? Okay, so up till now, what we have been adding is just basic shapes like box, sphere, maybe a plane, or things like that. But I think in actual applications, you might want to add like realistic looking objects, like an actual sofa set, a table, right? A shoe or something else. So the first question comes, well, where are you gonna get those things? You can go to Sketchfab, but this is Apple's website, and you can also download from Apple's website over here for the RealityKit stuff. And you can see they have a lot of different models available for you to use. They have shoes and donut and some toys and all that stuff. I have already downloaded this tea set or a teapot, and I'm just going to use that. But you can download any one you want. You can also download it from Sketchfab website. Sometimes you have to pay for it. And keep in mind that when you download it, each model is very different. So sometimes when you download the model and when you add the model to the real world, you might say, hey, where's the model? Like, I don't see any model. I just wasted like 20 bucks or $100 on this and I can't see it. Sometimes the model that you download from different websites might be so huge that you might be inside the model. So you will have to take care of the scaling, all right? So that's very common. Sometimes I will just add a model and I'm like, where's the model? And then I have to scale it to 0.02, 0.01, and then eventually I'll find out, oh, well, I was standing inside the model anyways, all right? Now I've already downloaded this model, which is right here. So now what we want to do is load this model. So I'm just gonna do it probably over here. There we go. Loading a model is actually quite simple. It's not that complicated. We are again going to use the model entity. So model entity.load. You pass in the name of the model, which is teapot in this case. And this is going to give you the model. All right, we're just going to use that. Don't use that, be safe, but I'm just going to use that. Well, once you have the entity, the only thing you need to do is to add it to the anchor, and you're done. So anchor.add entity or add child, we will add it to the entity, and then arview.scene.add anchor. Make sure you add it to the anchor, make sure you add it to the scene. Okay, this is not the best approach of adding a model, and you will see in a moment why. All right. Now, I believe these models are also lifelike or life size, meaning they should represent a real teapot. Once again, you can see our detection of our surface is taking a lot of time. There we go. And now if I tap, hopefully I can see the model. And I think this is the real life-size model, maybe. I don't know, it looks too big to me, but maybe this is the real size. You can go down to the model. I can see it over here. I don't know if you can see it over there, how shiny and nice and light is reflecting, very high quality model. So you can see they hired really nice designers. I don't know if this is a real size. You might know, but it might be the real size. It might be like a really big teapot. But you can see the light is reflecting even from this green, the silver part, you can see right there. And from this wooden handle, the light is reflecting. A beautiful model, all right? But if I add more models, you may see a little bit of a glitter, and you can see it's like messing it up now, or like actually completely messed up. But when I was adding multiple model, it would just glitch a little bit. And the reason was that I was doing all of that on the main thread. So you want to do that on the background thread, and you can do that or asynchronously. Now I'm not going to write that code. I already have some part of it. And we are going to use probably load model async. All right, kind of like weird formatting, but okay. So it's the same thing, but we are just using a load model async. I'm not sure why this is not defined. Let's go ahead and define this. Cancelable, any cancelable. Okay. So it's a different function. Instead of load model, we're using load async. Now you will see, I think if I can get multiple items to add, you will see that it's not as glitchy. It will be hopefully a little bit more smooth. And let's go ahead and take a look at over here. See, it's so fast finding it over there rather to compare to over there. Yeah, now it's too far, so I can't really go over there. But you can definitely see I can add and I can move my screen, and it's not like glitchy at all. All right, so I can add multiple teapots or any kind of a model that you have. All right. Okay, let's see over here. Okay, now the last example, which I just want to show you, and let's see if it actually works correctly, because that's a little bit hard example to show. It's about collision detection. How different objects can collide with each other. All right, so it's a bit of a code. So, but I just want to give you these possibilities, meaning that it can be done. And again, the problem will be this part over here. So what it should do is it should add like a plane, and it should add like a spear and certain other elements, and then I should be able to move and kick around some of the things. But again, you can see it's taking way too much time to find the plane. Let's help it out a little bit over here. There we go. Okay, it's kind of hard to do, and it's too big. The spears are way too big. Might have to go a little bit more far. Okay, so we have everything resting on that green plane, and the good thing is that I can actually move these things. Whoa, okay, whoa, okay. Oh, gotta be careful. All right, here we go. Okay, so it's kind of hard to see, but you can see that they kind of collide with each other. So I'm gonna try to come near over here. Okay, I think this might be a little bit better angle. So let's kick this one out. All right. And you can control and with your gestures. I don't know if you can make it bigger or something. Let's see, here we go. And these gestures are just one line of code, like install gestures, and it will install the gestures. And I can rotate it, and I can kick this one out. And now I have two remaining. One can be like really big, and you can see if it's growing. See, oh crap. Oh, no. Okay, it already fell down. I was trying to catch it, but it already fell. But you can see that we have now remaining one item only over here. And we can just do that with it. All right? So these are all the possibilities plus more that you can do with RealityKit. All right? And the last one, let's see, is text. You can also add text Maybe sometime you just want to add text somewhere, so you can definitely do that. Let me see if it actually works. All right. We'll see if it renders it at the correct location or not. But again, it's a little bit tied out over here. So apart from the green box, it should also add some text. Well, once it detects the plane, it's not really detecting anything right now, I guess. Okay, there we go. All right. And you can obviously put your text anywhere. I think it's just right at the bottom right now, but you can put it anywhere you like. All right. All right, so that is pretty much it. Let me go back to the slide. Okay. Source code for this, at least the first half of it, is over there into this GitHub repository. You can download the models that I've already shown you from the Apple's website. All right. And if you want to learn more, you can grab a copy of my course if you want. That link already should have the coupon already applied to it. It's on Udemy, so you can definitely check it out if you want to. And some of the resources, I would just say watch WWDC videos. So make sure that you understand Reality Composer also. All right. All right. Yeah, so watch Reality Composer video, watch the augmented reality videos on WWDC. I mean, they have a lot of content over there. I think if you also search for RealityKit book, you should see like a blog post from someone which goes through a lot of different stuff. It will take a lot of time to load because it's a pretty long blog post. All right, so this is my contact, and I think I am pretty much on time, hopefully. And thank you so much for coming.